Next operations I want to look at are when we're adding and we're subtracting fractions. These are the ones that when we talk about terms that we're used to, terms that we hear a lot or recall when we're talking about fractions, this is when we need the least common denominator. And again, the least common denominator, I'm going to say it doesn't necessarily need to be the least common denominator. As long as you have a common denominator, we're getting these on as even scales. And that's why when we have something like 1/2 plus 2/3, two fractions I just made up. Now, we cannot do these straight across. I know that the temptation is going to say, oh, well, I just say 1 + 2 is 3 over 2 + 3 is 5. That is not how we're able to add. We're going to need to get the denominator to be the same. Now, when we say least common denominator, what we're looking for is the least common multiple. But what you're going to see me often do, we don't often have to add these. And when we do, they're already in their reduced form. Oftentimes, these work out a lot easier than we want them to. What I'm going to say is always take one denominator times the other. I'm going to say take this fraction times 3 times 3. I'm going to say take this fraction times 2 times 2. What I'm doing is I'm using each other's denominator to get something in common. I'm going to say top times top is 3 over bottom times bottom. 3 is going to be 3 over 6. Now remember that 3 over 6 is the same fraction as 1 over half. If I had a candy bar with 6 parts and I ate 3 of them, that's the same as if I had a candy bar of 2 parts and I ate 1 of them. But what I have here is the other fraction where I have times 2 times 2. Well, that's going to give me 4 over times 2 is 6. That's still my same fraction. I'm not changing either fraction. That's still 1/2. That's still 2/3. But what I have now is a common denominator. This multiplied by each other's denominator may not give me the least common denominator, but all I care about is that it's the same denominator. As soon as I have that same denominator, I keep it, same denominator. Now, when I'm adding or subtracting, this is why the operation doesn't, adding and subtracting is the same operation. All I do is I add or subtract whatever my numerators. Now I have to follow whatever rules there are with positives and negatives and all of that, right? Whatever takes the bigger sign, all those same rules. That 7/6 is when I add 1/2 plus 2/3. Now, the same rules apply of whether I turn this is an improper fraction, which you're going to see. I like to use often more because that's the same as saying 7 apples is 6 oranges. But you will, depending on the teacher or depending on whatever the software would like us to do, we could still say 6 goes into 7 one time. What's left over? Well, I have 1 over 6. 1 1/6 is the same as 7/6. The operative word here is when we're losing our adding and subtracting fractions, I need that common denominator. I'm going to unreduce those 2 fractions. And again, the easiest way to do this is multiply by each other's. That gets me that common denominator. Doesn't have to be the least, but when I have that common denominator, I keep it, and then I add or subtract whatever the top is. That's how you add or subtract fractions.